Hello students, hope you all are fine and utilize your time in a productive and good way. So let's start with today's topic. Today's topic is event-driven programming. Before moving forwards to event-driven programming, and let us briefly understand what is procedural programming. Procedural programming is executed in a procedural order, whether it is from top-down approach or bottom-up approach, but the execution follows one particular order. Whereas in event-driven programming, code is executed upon activation of events. Say, for example, if a user press the keyboard any key, the event fires, or user moves mouse, the particular event fires. So in event-driven programming, code is executed when an activation of appropriate event fires. An event can be defined as a type of signal to the program that something has happened. The event is generated by external user action such as mouse movement, mouse click, and keystroke, or by the operating system such as a timer. Every time the user taps a character or pushes a mouse button, an event occurs. Any object can be notified of the event. All it has to do is to implement the appropriate interface, and it best be registered as an event listener on the appropriate event source. Graphical user interface, abbreviated as GUIs, are event driven. It generates events when user interact with GUI. For example, if user wants to close the window, the close button is clicked and the screen will be shut down. The event is closing the screen. For another examples of GUI events are moving mouse, pressing button, typing the text field, etc. And the class for event-driven programming required is the AWT event, which is inside the package of java.awt. AWT is the abstract window toolkit. Here on diagram is given of event classes. Go through it. Event delegation model provides a standard mechanism for a source to generate an event and send it to a set of listeners. An event is an object that describes a state change in a source. Some of the activities that causes events to be generated are pressing a button, entering a character via the keyboard, selecting an item in a list, and clicking the mouse. Events may also occur that are not directly caused by interaction with a user interface. For example, an event may be generated when a timer expires, or a counter exceeds a value, a software or hardware failure occurs, or an operation is completed. Event handling model, there are three major parts that we need to understand: the event source, event object, and event listener. Source is the object that generates an event. This occurs when the internal state of object changes in some way. Sources may generate more than one type of event. A source must register listeners in order for the listeners to receive notification about specific type of event. Second is event object. Event is an object that describes a state change in source. It can be generated by clicking the keyboard key, or moving mouse, or closing the window, or double clicking the mouse, anything. The third is event listener. Event listener is an object that is notified when an event occurs. It has two major requirements. First, it must have been registered with one or more sources to receive notification about specific types of event. And second, it must implement methods to receive and process this notification. Programmer must perform two tasks. First is register event listeners for event source, and second is implement event handling method that actually has a coding of what to do when particular event executes or when particular event fires. Here one example is given. The JButton class is created and the object JBT is declared. The button label or caption is given as an OK. The action listener class and its object is created, named with listener, and jbt.addActionListener. addActionListener is the method of JButton class which actually add the listener. Here the listener is the listener object. Event class and listener interface listener methods are given. Action event, item event, window event, content event, all are the classes, whereas action performed, item state changed, window closing, window open, window iconified, window de-iconified, window closed, all are the methods. So just go through it. Next is inner class. Inner class is a member of another class. Inner class can reference the data and methods in the outer class in which it nested. So you do not need to pass the reference of the outer class to the constructor of the inner class. Or in other words, an inner class is defined within the scope of an expression or another class. Therefore, it has access to the variables and methods in that scope. One example is given, and the basic structure how the inner class can be declared is given first, and second is with the whole example is given. So let's go with the general structure. The class is test, and the second inner class named A is defined in diagram A, wherein is in diagram B public class A is the inner class. Let's see the whole example with diagram C. The outer class is named as an outer class with one variable data which is of type integer and private. Second, outer class has a method m. Do something can be the code that you want to execute when m method is called. Next, the inner class is defined in the class outer class. So inner class is itself an inner class which has one method mi, and in that method we are using the variable of outer class data and we are incrementing it by 1 and we are calling m method. Here the advantage of inner class is that you do not have to pass the reference of outer class to access the methods and variables of outer class in inner class. Here the data variable and method m is defined in outer class, but we are using directly from the inner class, so we don't have to pass the reference. That is the most beneficial. Inner class can make programs simple and concise, and inner class supports the work of its containing outer class and is compiled into a class named outer class inner class. For example, inner class in outer class is compiled into outer class class.inner. An inner class can be declared public, protected, or private, subject to the same visibility rules applied to a member of the class. Inner class can be declared static also. A static inner class can be accessed using the outer class name. An inner class can be declared static. A static inner class can be accessed using the outer class name. A static inner class cannot access non-static members of the outer class. Next topic is anonymous class, anonymous inner class. Anonymous means without name. Anonymous inner class must always extend a superclass or implement an interface, but it cannot have an explicit extends or implements clause. An anonymous inner class must implement all the abstract methods of the superclass or the interface. In other words, anonymous inner class is an inner class that does not have a name. The syntax to define an anonymous inner class is just simply assign use a new keyword and class name. Inner class listeners can be shortened using anonymous inner class. An anonymous inner class is an inner class without a name. It combines declaring an inner class and creating an instance of the class in one step. The basic general syntax is given, new keyword is used, then the superclass name or interface name, then the body of the class. Some mouse event classes methods are given with their description. The main package required to use mouse event class is the event package, AWT package. Here get when then is control down, is mid down, is shift down, get button, get click button, get point, get x and get y, all are the methods of mouse event class. The descriptions of each method is given, so just go through it. Next is handling mouse event. Java provides two listener interface, mouse listener and mouse motion listener, to handle mouse event. The mouse listener listens for actions such as when the mouse is pressed, released, entered, exited, clicked or double clicked, or anything that user can interact with mouse. That all type of events are handled using mouse event class. The mouse motion listener listens for actions such as dragging or moving the mouse. Next, the list of mouse events are given with their use, with their description, and the syntax is given here. Void is the return type of each method. The name is mouse pressed. It takes one argument, that is e, mouse event class object, and the return type is void. Same for all the methods. Mouse released is the name of the method. It takes one argument of mouse event and object e. The return type will be void, and the description is given besides invoked when the mouse button has been released on the source component. So just go through all the methods and read the descriptions of each method. Next is handling keyboard events. To process a keyboard event, use the following handlers in key listener interface. The methods are key pressed, key released, and key type, respectively called or executed when key is pressed, when key is released, and when key is typed. So thanks, and feel free to comment for any doubt.